scenario, right now. So what will happen? Tell me. Let's suppose PC number 1 wants to communicate with PC number 3. Fine. This is the scenario, na? Tell me. This is the scenario. So what will happen in this case? So PC number 1 generate this packet. ARP. Which packet? ARP request. Fine. ARP request will reach on switch. This is the broadcast packet right now. So what switch will do? First of all, maintain its cam table and broadcast it. Fine. This packet will reach on switch number 2. Again, switch number 2 check the source detail and maintain its on cam table. Right? And broadcast it. Clear? Understand till now? And this ARP request is for which PC? PC number 3, na? So, entire PC number 2 and PC number 4 will drop that packet. Only PC number 3 will accept it. Fine. Now PC number 3 will generate which packet? ARP reply. This ARP reply is a unicast, multicast, or broadcast? Unicast. This ARP packet will reach on the switch number 2. What switch number 2? Will do. Switch number 2 again make entry in which table? Cam table, and forward this packet through, towards only switch number 1, not towards here, because this is the unicast, right? This packet will reach on switch number 1. What switch number 1 will do? Again make entry in its cam table. Tell me yes or no. And forward this packet towards PC number 1. Fine, understand? For switch number 1, let's suppose MAC address is 0A, interface is 0 by 0, interface is 0 by 2, 0. Let's suppose interface is 0 by 1, and let's suppose the interface is 0 by 2. Fine. So what will happen? So first of all, PC1 generate the ARP request. Here reach PC number 1 learn 0 by 0. MAC address is 0A. Fine. And forward towards here. What switch number 2? Switch number 2 entry is 0 by 2. MAC address is 0A. Fine. And forward here. PC number 3 generate the ARP reply. Packet will reach here. Let's suppose MAC address is 0C. Switch number 2 will do. Let's suppose 0 by 1. And 0 by 1 I am receiving 0 by 0C. And switch number 2 forward that packet towards switch number 1. Switch number 1 will what will do? Switch number 1 on 0 by 2 receiving 0 by 0C and forward towards PC number 1. So these are the entry. Sorry, PC number 2, PC number 3. Yes, yes. This MAC address will update on switch number 1 as well. Okay. So basically, this is the way how packet flow where in in same subnet. Clear? Okay, now it's working. So I told you na there are two types of messages. First is which is ICMP request and ICMP reply. So let's suppose if you are pinging ping 192.168.1.3, it means you are pinging the destination right now. If you are pinging the destination, what will happen? See, there is success rate is 80%. Why? Why there is a success rate is 80%? First packet is dropped to learn. Are you sure?
First packet lost due to it search the ARP request.
Excellent. Because between source and destination, ARP packet is exchanging here, guys. So that's the reason your one packet or first packet is dropped. Fine. That's the reason you are able to see 80% here. And when you run this command again, you will see the 100%. If I run command show ARP here on PC number 1, I am receiving this one. What is this? ARP table, guys.
ARP table.
This is ARP table. Fine. This is the IP address and this is the MAC address. And this is the interface of PC. Interface of PC. Clear, everyone? Now,
Yes.
if we are talking about this one, see, this is, what is this? This is, I just capture this, okay? I just capture the link, then I will find source IP address is 192.168.1.1 and destination is this one. And this is the, which protocol is there? ICMP, and this is the ICMP request. This is the ICMP request. And PC number 3 is generating the ICMP reply with source 1.3, destination 1.1, and this is the ICMP reply. This is basically, yes, you can see the ICMP use protocol number 1 when you check the which header, ARP header. When you check the ARP header, then in Wireshark, yes, in Wireshark you can see the this one. In when you capture the link, let's suppose here, fine, let's suppose if you capture the link here, fine, then after you can check up, and you can easily check in packet tracer. In packet tracer you can check, fine. So this is the, yes, I will show you, don't worry about it. Now, mhm, yes, guys, basically for this you need, yes, you need to, basically you need to remember these things. We have yes, we have some protocol generally in day to day we are using. I will tell you about one by one. Definitely you guys need to remember but these things, fine. No, this is not something a table, but let's suppose if I am telling you the switching part, let's suppose if I am talking about the DTP, if you are talking about the VTP, for every protocol I will tell you about these things. So you have and finally you will have a list. Otherwise, at the last classes I will tell you about the list. Fine. So see, this is the command to check the MAC address table. So MAC address table, fine. And you know na, by default every interface of a every interface of a switch, yes, is a part of VLAN number 1. And by default VLAN number 1 is a called native VLAN, fine. And this is the MAC address, fine. Type is dynamic. It means these MAC address switch learn these MAC address dynamically here. On which interface? Gig 0 by 0 and 0 by 2. Clear? Under that there is static. Generally we are not using static we are using in real scenario you are using static. Let's suppose if in your organization if you have some PC, let's suppose this is the uh, finance PC and this is some critical PC. So what you will do, you will just bind this MAC address with the switch statically, fine. So yes, I will show you. This is, there is a command to just create the static MAC address here. Clear? Understand? Yes, you can say you can update the CAM table or you can make the entry in the CAM table manually by the help of static MAC address. And let's suppose if you want to clear the dynamic MAC address, what is the command? Clear MAC address table dynamic. Clear? MAC address table dynamic. Yes, if you do not want to wait for the 300 seconds, yes, you can clear these things. Fine. Let's suppose in CAM table, let's suppose there are multiple MAC address. If you want to clear only a particular MAC address, then what is the command? Clear MAC address table dynamic, and after that write address and just paste the MAC address. Fine. So by the help of this command, you can just erase or remove that particular. Yeah, similar go to the static as well. And let's suppose if you do not want to copy this one, if you want to just remove the MAC address from gig 0 by 2, what you can do? Clear MAC address table dynamic interface gig 0 by 2. By the help of this command, you can also clear it. Clear, everyone? See, you are telling na 0x0800. See,
Yes, sir.
0x0800. Why? Because you are using IPv4. Fine. Similarly, you can see here there is a ARP and value will be 0x0806. Understand? Everyone. See na? I think you are asking
Yes.
that this same question, right?
Yeah.
Acha, okay, got it. So, so this is the way how switch will take the forwarding decision. I hope you guys understand these concept, right? Tell me. Okay. Now, after that, we can start from the first topic of switching, that is called VLAN. That is called VLAN. Just give me a minute. Let me clear it first. If you guys want, I will share the this PPT with you. If you guys want. Yes, I hope maybe when you read these concept, na, it will help you.
Yeah,
Fine.
yeah, do share, yes.
Okay. Let's start the first of all VLAN part. Okay, what do you mean by VLAN? What is the full form of VLAN?
Virtual LAN?
Virtual
LAN.
virtual LAN.
Virtual local area network.
Yes, virtual local area network.
Network.
Point number two. First of all, if anyone asks you very simple question, what is the use of VLAN? What is
Limit
the
the
use
broadcast.
of
VLAN.
VLAN? So why see? Basically, na, let's suppose try to understand. This is the switch. 1, 2, 3, 4, 5. How many users are connected?
5.
5. Let's suppose this PC generate ARP request, and you know na this is the broadcast, right?
Mhm.
So when this ARP request will reach on this switch, what switch will do? Switch will broadcast it. Tell me yes or no.
Broadcasters. Broadcast packet.
Let's suppose this PC belongs to IT department. These two PC belongs to finance department. This is belongs to, let's suppose, sales department, and this is the account department. And this PC1 generate the ARP request, and this ARP request will reach on every PC. But tell me one thing, actually these PC do not need any types of information from this PC. Tell me yes or no. Yes.
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 But when this ARP request is reaching on switch, what switch is doing? First of all, What switch will do? First of all, switch learn the address. Tell me yes or no. Learn. After that,
Yes.
switch will take the forwarding decision. But how? On the basis of destination MAC address. Tell me yes or no. Yes,
Yes.
but
Yes.
no. Before checking the destination MAC address, switch will check I am receiving this packet on which interface? 0 by 0, let's suppose.
Okay.
Then switch will check my 0 by 0 interface is a part of which VLAN. Then switch will find by default there is no VLAN configuration. It means by default all the interface is a part of VLAN number 1. It means this
Okay.
interface is also a part of VLAN number 1.
Okay. So there is a table kind of for a VLAN also, like a CAM table for
Like a CAM
checking.
table, yes, when you can check by the help of command show VLAN brief. When you run this command on the switch show VLAN brief, you can see in VLAN number 1 all the interface is mapped in
Correct.
VLAN
With
number
that.
1.
Yes.
Fine. So basically switch check 0 by 0 is a part of VLAN number 1 and I am receiving this broadcast packet. So what switch will do? Switch will forward this broadcast packet to every interface which is a part of VLAN number 1. It means right now all the interface is a part of VLAN number 1.
VLAN
It
one.
means all the PC will receive that broadcast packet. No matter this R packet belong to these department or not. But
Okay.
all the department will receive it. Getting my
It's
point?
It's
Tell me
unknown
everyone.
unicast packet, unknown broadcast
Yes,
packet. Yeah?
you can say unknown unicast packet or broadcast every packet. For every packet which will broadcast it.
Okay.
Fine. So try to understand what is happening here. Happening what? Basically right now every interface is a part of VLAN number 1. It means right now on this switch only one broadcast domain. Only one broadcast domain. One broadcast domain means if switch will receive any broadcast packet, switch will forward that packet through every interface, because on switch right now or by default only one broadcast domain is there. Tell me yes or no. Yes.
Yes.
But let's suppose I want to break the broadcast domain on layer number 2. How we can break this? By the help of VLAN. By the help of VLAN. So that's the reason. What is the point number 2? Point number 2, we can break broadcast domain at layer number 2 by the help of VLAN. By the help of VLAN, we can we can break the broadcast domain. How? Try to understand. Let's suppose this is the switch. Again, same scenario. PC number 1, 2, 3, 4, 5. This is IT department. These are finance department, sales department, account department. Let's suppose this finance department belongs to VLAN number, let's suppose 10. Fine. This is VLAN number by default 1. Let's suppose this is VLAN number 10 and this is VLAN number, let's suppose 30. What will happen? This PC generate the broadcast packet. This broadcast packet will reach on the switch. Switch learn the source address and make an entry in its CAM table. Now switch will check I am receiving this interface, this packet on which interface? 0 by 0. And 0 by 0 is the by default part of which VLAN? VLAN number 1. So what switch will do? Switch will broadcast this packet through all the interface which is the part of VLAN number 1. But guys, tell me one thing. On switch right now, any port is a part of VLAN number 1? No. Any port is a part of VLAN number 1? No.
No.
So now what switch will do? Switch will do not broadcast this packet through all the interfaces. So by the help of these VLAN, we can break the broadcast domain here. So if anyone asks you very simple question, how many broadcast domain is here? 1, VLAN number 1, second VLAN number 10, VLAN number 30. And again this is also a VLAN number 10. So how many? VLAN 1, 1 broadcast, VLAN 10, second broadcast, VLAN 30, 3 broadcast. Total how many broadcast domain? 3 broadcast domain. So by the help of VLAN, we can just break the broadcast domain at layer number 2. And at layer number 3, how we can break the broadcast domain? By the help of IP address. We will discuss it later. But at layer number 2, we can break the broadcast domain on the basis of VLAN. I hope you guys understand. Clear? Tell me.
Yes.
Yes, sir, understand.
Okay. Point number 3 about the VLAN. We can identify a VLAN by the help of number. Identified by number. We can identify a VLAN by the help of number. And what is the size? Size is 12 bit. What is the size, guys? 12 bit. Clear? Understand? This is the size of VLAN. Point number 4. What is the range of VLAN? 0 to 4095. This is the range of VLAN. And this range is also divided into two categories. First is standard and second is extended.
Mother comes up.
What is the range of standard? 1 to 1005. Extended is 1006 to 4094. So this is the extended. Clear, everyone? Point number 5. By default, which VLAN is configured on every interface? VLAN number 1. By default, VLAN number 1 is configured on all the interface. So if VLAN number 1 is configured on all the interface, it means by default on a switch, how many broadcast domain? 1.
Single broadcast domain.
Single
Sir,
broadcast
can we
domain.
say the
Right?
single or we have to say one broadcast domain?
Same. You can say single broadcast domain. Clear? Understand?
Okay, sir. Okay, sir.
Next
त्याची
point is,
परीक्षा आहे ना उद्या
guys,
त्याची.
let's suppose if I create VLAN number 10, VLAN number 20, VLAN number 30 on the switch. So definitely this is the database of the switch. Yes or no?
Sir, there is noise
चला
from
मग माझं
someone.
उद्या मारतो.
Can you please mute
Sandeep,
them?
please mute.
मी एकदा खाऊन
संदीप.
जातो बसतो. ठीक आहे तुझं अजून वेळ आहे ना तोपर्यंत
Sandeep, please mute.
Sorry.
Hi Daniel, are you there?
Yes, sir. Okay.
Daniel, are you there? Okay. So what I am telling, guys, I am telling, let's suppose on switch I create 3 VLAN. VLAN 10, VLAN 20 and VLAN 30. It means definitely these are the database for the switch. Yes or no? Yes. This is the
Yes.
database on the switch. So my question is, where switch store VLAN database? Where switch store VLAN database? So please remember, switch always store its VLAN database in which memory? Flash memory. In which memory, guys? Flash memory. Basically in flash memory there is a folder. What is the name of that folder? VLAN.dat file. VLAN.dat file. Basically in this folder switch store all the VLAN information in flash memory. Clear? I hope you guys understand.
This is a folder or this is a file name?
It's
Yes.
clear? Okay. Now let's suppose if we have scenario like this. Now let's suppose 10.1 wants to ping 10.2. What will happen? By default, I am just telling you, by default every interface is a part of VLAN number 1. So Sachin, tell me what will happen if PC number A wants to ping PC number B?
PC number A uh, ja- request
So see,
and
if all the interface is by default a part of VLAN number one, it means there is a simple packet flow. Again, PC
okay. So
number A don't know what is the MAC address of.
switch will broadcast this packet for all
Okay.
PCs.
So first of all, this PC generate which packet? R packet. Sorry, ICMP
Or
packet. ICMP. But in ICMP, PC number A don't know what is the MAC address of PC number B. So that's the reason this ICMP packet will hold and
And it
A
will get the
generate the
R
R
request.
packet.
Yeah.
And this ARP reach
request.
on switch. What switch will do? Switch make a entry and switch will broadcast it. Broadcast it. Clear?
Yes, sir.
PC number C and PC number D drop this ARP request and PC number B will accept it and generate the ARP reply. Fine. This ARP reply will reach on this interface. Switch again make an entry in its CAM table and forward this packet towards the PC number A. And again PC number A update its ICMP packet and forward this towards switch and communication will happen. Understand now, everyone?
Yes,
Yes.
sir.
But try to understand if we have next condition, A and B is a part of sales department and C or D is a part of, let's suppose, account department. And what is the condition? Condition is all sales department can communicate with each other and all account department can communicate with each other. But there is a restriction. Restriction is sales department data will not forward to account department and account department data should not forward towards sales department. How can you achieve these tasks?
Okay.
How can we achieve this task? So see, by default, all the interface is a part of VLAN number one. Tell me yes or no. Yes.
Yes.
So if
So we
all
need
the
to
interface
create
is a
VLAN.
part of VLAN number one, it means there is only how many broadcast domain? One broadcast domain.
One broad.
So
One
it means
broadcast.
if any PC generate any broadcast packet, that packet will reach on every PC. Fine. But right now, how many departments we have? Two department. One sales and
Two.
second is account. So it means we need to break this broadcast domain in how many domain? Two domain.
Two domains.
Because right now I have how many domain guys? Two domain, sales domain or account department. So we need two domain here or two separate department. And how we can break these department by the help of VLAN. So what we will do? We will configure these two interface is a part of VLAN number 10 and these two interface is a part of VLAN number 20. Getting my point, everyone? What we will do? We will configure these two interfaces a part of VLAN number 10 and these two interfaces a part of VLAN number 20. So what will happen if this PC generate any broadcast packet, this packet will reach on the switch. What switch will do? Switch will check the packet. This is the broadcast, but this switch will broadcast this packet through only this interface. This switch never broadcast this packet towards here. And by this we can achieve these tasks. Sachin,
It
I
means
hope you understand.
we can say that number of VLANs is equal to number of broadcast domains.
Yes, you can say yes, definitely. If anyone asks you this question, ki, how can you calculate the number of broadcast domain on the switch? You can calculate it by the help of number of VLAN.
Okay.
Sachin, it's clear. How can you
Yes.
achieve this task?
Yes, sir. Yes, sir. By the creating number of VLAN.
Number of VLAN.
Okay, one
Clear?
question, sir.
And let's suppose
Yes.
if anyone asks, yes, Sandeep,
Can
Yes.
one port of the switch can be a part of two different VLANs?
two different VLAN?
VLANs.
No,
No.
no.
Okay.
On
Then
If
how the
one,
voice?
one,
Yeah, go
one
ahead.
Yes,
single port cannot part of two VLAN.
yes, two VLAN. for let's suppose on a or through a single port you want to send multiple VLAN data, what you
Yeah.
need to do? You need to configure that port as a trunk port. This is the
Yeah.
next concept. What we will do, we will configure that port as a trunk port. And what is the function of trunk port? And through the trunk port, we can send multiple VLAN data.
Yeah.
Fine. So
That is
Sachin, what I'm trying to say, let's suppose if we have scenario like this, switch one, switch two, I have PC number one, PC number two, PC number three, and here one more PC, PC number four. Fine. Let's suppose there are more four PCs. Clear? What I'm trying to
Yes.
say, let's suppose these two are the sales department, and here this is the sales department. Clear, everyone?
Yes.
This is the account department, and this is the account department. Now your concern is, or now my requirement is, sales department can communicate with the sales and account can communicate with the account. Let's suppose these two is a part of VLAN number 10, and here these two is a part of VLAN number 10. These two is a
Yes.
part of VLAN number 20, and this is the part of VLAN number 20. Is sales department able to communicate with the sales right now? Answer is no. Why? Because try to understand. Let's suppose this PC generate any packet, any broadcast packet. Packet will reach on switch.
Switch one.
What switch will do? Switch will check. I am receiving this packet on this interface, and this interface is a part of VLAN number 10.
Yes.
10.
So what switch will do? Switch will forward this packet through this one, because this port is also a part of
This
VLAN
is
number.
also VLAN in
Okay.
VLAN number 10.
This switch
Okay.
never forward that packet through this interface, because these two interfaces is a part of VLAN number.
20.
20.
Okay.
And on this interface, I do not configure any VLAN. So by default, this is the part of VLAN number.
1. Native
So
VLAN.
it means, yes, so it means this switch never forward this packet towards here. So if
Okay.
this packet never reach through this interface, then how this PC will able to communicate with this PC? Not possible.
Yes.
So we have to configure
Yes, you
that
can.
port which connected with switch 2 on same VLAN
What
on
you
VLAN
can do?
number 10.
What you can do? Let's suppose on this interface you can configure VLAN number 10. Fine.
Okay.
And on this interface you can configure VLAN number 10. Yes,
Okay.
definitely. Then after you are able to communicate here. But try to understand the problem. Let's suppose now this PC wants to communicate with this one. Then again you
Then
will configure the VLAN number 20.
Okay.
No, this is not the network engineer task. At every second you are here to configure VLAN. No. Yes, you can do one thing. Let's suppose you are telling, let's suppose I just connect one more wire here. And one wire I connect in VLAN number 10 and one wire I connect in VLAN number 20. Yes, communication will happen, no problem there. But try to understand, in real scenario, there are multiple VLAN in your organization.
Okay.
And on the switch, there are only limited ports. On the switch, there are only limited ports.
Limited ports.
Okay, so this is not the permanent solution here. So what you can do, guys, you can configure this link. Instead of using multiple link, what we can do, we can create one link as a trunk link.
One port. Okay.
We can, instead of using multiple interface or multiple port, we can use one port and we can configure that link as a trunk link. And what is the function of that trunk link? By the help of trunk link, we can forward multiple VLAN data. Multiple VLAN data. I
But
hope
can we
you guys
restrict that?
understand.
One thing. Suppose we have 10 VLANs, 10 different VLANs. Can we configure
Yes.
trunk link only to carry 10, 20, and 30 VLANs
Yes,
through that?
yes,
We
you can,
It's a
we
conditional.
can do.
We can do a conditional forward.
Yes, we can just configure these things. Let's suppose by default every VLAN is allowed on the trunk. We can restrict it.
So
Getting
we
my
can
point?
Okay. So that port we can configure to carry only VLANs of 10 and 20, not 30 and 40.
Yes, definitely. Yes, we can restrict it
Okay.
on the trunk port, on the trunk
Okay.
link.
Okay.
Clear? Let's suppose if anyone asks you, what do you mean by switch port? What do you mean by switch port?
Which port?
So
No, sir.
basically,
Don't
switch
know.
port means a port which transmit the data on the basis of layer 2.
Okay.
On the basis of
Layer
layer
2.
2. Try to understand what I am trying to say. Let's suppose this is the switch port, and how many types of switch port? Either your port will be access port,
Access
or
or
either
trunk.
your port will be
Trunk.
trunk port.
Okay.
Either is access or either is trunk. If I am talking about the access means it carry single VLAN data.
Hmm.
Single VLAN
VLAN data.
data. Sachin, you understand access?
Yes, sir. Yes, sir. Access. Understanding.
Access means single VLAN data.
Single
Fine.
VLAN data.
If I configure any port as a trunk port, it means it can carry multiple
Multiple
VLAN data.
VLAN.
Multiple VLAN. Okay.
It can carry multiple VLAN data. Let's suppose if we have scenario like this, let's suppose this is the switch number 1, this is the switch number 2, here 4 PCs are there. Fine, clear, understand?
Yes.
And I
Yes.
configure this one as a access port for VLAN number 20. So this link is known as which link, guys? Access
Access.
link.
Access port.
Because on this link you can send only and only
VLAN
which
10.
VLAN data?
10.
VLAN 20 data.
20. Okay.
Let's suppose if I configure this link as a trunk link. So if I configure here as a trunk link, it means this link can carry VLAN 10 as well as VLAN 20, VLAN 1, every data from this link. Getting my point, everyone?
Yeah.
Okay. Yes, sir.
Understand?
Yes.
Now, if you guys understand these concepts, I hope you guys, first of all, I hope you guys understand the VLAN concept, why we need VLAN. Tell me yes or no.
To break the broadcast.
Yes, to break the broadcast domains.
To break the broadcast.
Okay.
To
Tomorrow
separate
I will
the network.
tomorrow I will show you the practically as well how we can configure the VLAN, as well as how we can configure or move any port as a VLAN port. Fine. Practically I will show you. Clear? Tell me.
Yeah.
Yes, sir.
Sandeep, clear?
Yes. Yeah.
Daniel, are you there? Okay, cool. Then I hope you guys understand what is the use
But
of trunk.
can you, sir, explain here the voice and data? We create a voice VLAN and data VLAN, where we can because this is what we
Yes,
are configuring in the
how
office.
we can create the voice VLAN, and how see the simple thing about the voice and VLAN. Just remember one point about voice and VLAN.
Uh,
Basically, let's suppose if you are working in any organization,
yeah.
fine, there are two VLAN or two types of data. First
Mm.
is voice data, and second is data, or you can say data VLAN. Data VLAN means basically through that VLAN you are, let's suppose if you are searching anything on the Google,
Mm-hmm.
if you are searching anything on the Google, if you are downloading anything from the Google, everything will belong from which VLAN? Data VLAN.
Okay. So
Data
no,
VLAN.
what I fail to understand here, we are creating VLAN 10, 20, 30. So how the
Mhm.
voice and data correlate with this?
See, basically na voice, if we are talking about the voice and data na, basically if in an organization, how organization work, let's suppose in my organization we are working, let's suppose we are using VLAN number 179 and here is
Mm-hmm.
VLAN number 101. We are
Okay.
configure 101 as a data VLAN, and this
Okay.
is voice VLAN.
Okay.
Getting my point? Let's
Okay.
suppose in my company there are multiple projects. Let's suppose in my company there is a project Amazon. One project is Charter. Charter is the project which is, this is international project. Let's suppose in Charter project we have all the work on the Google, or you can say on the cloud. Fine. So definitely these project belongs to which VLAN? Data VLAN. Fine. And
VLAN
in Amazon,
101.
Amazon, every user is working in, let's suppose BPO call center. I hope you guys know, right? So in
Yes.
Amazon, users are belonging from the voice VLAN. So according to the quality of services. So these are more priority than data VLAN, right? So what we can do in voice VLAN, first thing, your quality of services is high, because it means in voice VLAN data is more prior than data VLAN. First thing you guys need to remember. If anyone asks you, just tell him in voice VLAN data is more prior than data VLAN because quality of services is high compared to data VLAN. First
No, no,
thing.
sir,
Second
what I,
thing.
one question. See, we create VLAN 179. We give this
Mhm.
VLAN name as a voice. So VLAN
Yes, you can
has
you
two
can configure.
parameters. One is a number and one is a name, like a computer
Yes.
has. Computer has an
Mhm.
IP address and computer has a name.
Mhm.
So similarly, you
Yes,
can
sir.
say
Can
that.
we?
Yeah.
Yes.
Yes, sir.
Let's.
Can we use this VLAN? Can we use this VLAN? uh, एक दूसरे के अलग अलग भी हम यूज कर सकते हैं क्या, जैसे 179 कैन वी यूज फॉर
No.
डेटा एंड कैन वी?
Nine, nine. See, try to understand what will happen. I'm just talking about in real scenario. In real scenario, what you will do? Let's suppose in my organization or in your organization, let's suppose you are using 101 as a voice VLAN. So let's
Yes.
suppose what you will do, on switch you create VLAN 101 and you just configure VLAN 101 name what is voice. Fine. And
Okay.
in voice VLAN there are multiple parameter we can run quality of services or multiple things. That is the different thing. Fine. Let's suppose we did these things. Let's suppose I create one more VLAN 179 and name is data.
Data. Okay.
Fine. Let's suppose there are 50 users, LAN users are there,
Yes.
and there are
Okay.
50 LAN users are there, and
Yes.
these 50 LAN users are belongs from Amazon project, and these users belong to charter. What we will do, all the charter user I will move in which VLAN 179, and these users in which VLAN voice VLAN. Let's suppose if you are asking can I move this user in 179 and this user in 179, yes,
Yeah.
definitely there will be a problem is, let's suppose if we are creating this VLAN, voice VLAN, in voice VLAN multiple things are allowed, multiple things are not allowed, because we already set here quality of services. And in quality of services, if you are achieving the quality of services, multiple things are allowed and multiple things are not allowed. Getting my point?
No,
So
no, no.
yes,
Sir, one
we in
question.
real scenario we can't do like this.
Uh-huh. Okay.
Getting my point, Sachin?
yes sir, yes sir.
Basically na you are facing multiple ticket and you are getting multiple ticket related to this. Let's suppose if any engineer move any port, move, let's suppose 1012 to 179, and user is suddenly facing challenges and user is raising the ticket ki I am not able to access these tool, my voice is dropping, multiple things. What is the problem here? Problem is you move this LAN port into the 179. You need to move 179 to 101.
No, but sir, sometimes we require data and voice together on single port because they are first connected to
Yes,
the telephone.
yes,
Yeah.
sometimes we require, yes.
In that case, yeah, that is the clutch there. So what's happening in our organization? We have got some of the users connected to the phone and we get receive the data from the phone. And only one
Yes,
cable is going to the phone as a voice, as a trunk line. And from there, from the phone, we are connecting a PC.
yes,
So in that scenario, how we should configure this?
Okay,
so
I think I can explain this. So what happens is, I think you're talking to Cisco IP phones, right? You're referring to Cisco
Cisco
IP
or
phone.
even
yes, that's
NEC,
right.
anyone.
Yeah. So what happens is, in the Cisco IP phone, there is another small switch in it, and we tag
Exactly,
the
yeah.
voice VLAN. We tag the voice VLAN in the network, and
Yeah.
the switch to be able to identify which is which. So we don't. So the day, I mean, when we pass the tag info, then it will be take its IP from the voice VLAN, Cisco
Uh,
IP phone, And then there is another Ethernet port to the Cisco IP phone, right? It will
Yeah,
be
correct.
connected to the laptop, and the
Yeah.
laptop will able to take the IP from the actual access VLAN, which is
Actual access VLAN, yeah.
actual
This
data VLAN that is passed on that particular site.
correct. But where the quality of
Yes.
service are we define? Yeah.
So
Yes.
that I don't know. That maybe
Yeah. This is that I have done it in the office, but sometimes we have a problem with the voice. Sometimes the voice. So this is what I am coming to. How we can clarify these things.
I think they pass some QoS commands like make it prioritized.
Yeah, probably sir. Yeah.
Okay. Now, next is guys, let's suppose if you are using the trunk link. If you are using the trunk link, let's suppose if you are sending the data, let's suppose this is the switch 1 and this is the switch 2 and there are multiple users. Let's suppose here VLAN 10 are there, VLAN 20 users are there, 10 users are there and 20 users are there. Let's suppose if we configure this as a trunk, it means VLAN 10 is able to communicate with VLAN 10 and VLAN 20 is able to VLAN 20. There is no problem. Tell me yes or no. Yes?
Yeah.
Yes.
Yes. Yes.
But if you are sending the data over the trunk, it means what is the use of trunk here? Trunk
Carry all the
perform
information
tagging.
of VLANs.
Trunk
Tagging,
also perform tagging. Na? Let's suppose if switch 1 forwarding any VLAN info, let's suppose VLAN 10 data towards VLAN number 2, sorry, switch number 2, then how switch number 2 will understand this packet belongs to VLAN 10 or VLAN number 20? By the help of
tagging.
tag.
Tagging.
And
Trunk port, it means trunk port work is forward the all VLAN.
yes, Sachin, basically, let's suppose if you configure this as a trunk link, it means trunk link can forward your multiple VLAN data. Let's suppose on switch number 1, if we have VLAN number 10 and VLAN number 20, if you configure this link as a access link, then you are not able to send multiple VLAN data. Yes, but if you configure the trunk link, you can send the multiple VLAN data over this trunk link. Fine, but try to understand what is the problem. What I'm trying to say here, if this is the switch number 1, switch number 2, and this switch are connected like this, and there are 4 users. These 2 users belongs to VLAN number 20. These 2 users connected to VLAN number 20. Again, 4 users. VLAN number 10 and VLAN number 20. Yes, there is a no problem. VLAN number 10 can communicate with VLAN number 10 and VLAN number 20 can communicate with VLAN number 20. There is a no problem. But try to understand what I'm trying to say. If this user send any data, this data in reach on switch number 1, if switch number 1 forward this packet towards switch number 2, then how switch number 2 will understand this packet belongs to VLAN number 10 or VLAN number 20? By the help of tagging.
Tagging.
Trunk port. Okay.
Understand, Sachin? By
Yes,
the
sir.
help of tagging. So basically, this is the functionality of trunk link. Trunk perform the tagging.
Okay. Trunk, it means tag. Tag port.
Tag port, yes, you can say, but basically, if we are configuring the trunk, basically nothing is happening automatically here. How trunk link? If you configure the trunk link, how trunk link perform tagging? Basically, there are some protocol. There are some protocol. On the basis of that protocol, basically trunk perform the tagging. What is the name of that protocol? That is called trunk encapsulation protocol.
Which one?
Trunk encapsulation protocol. There are two types of protocol. First is .1q and ISL. This is the ISL is a Cisco proprietary, but nowadays we are not using ISL. We are using .1.
Dot one.
Understand, Sachin? What is
Yes.
.1q? .1q and ISL both are the encapsulation protocol, and by the help of this protocol, trunk link perform the tagging. Trunk link perform the tagging.
Right.
Clear? Understand?
Yes, sir.
Okay. Now, if we are talking about basically in real scenarios, we are not using ISL. Okay. but I'm just telling you something about the ISL. You guys just need to remember these things. Okay. In ISL, if you are using the ISL add how many information, how much information with your original packet, that is 30 byte. What is the information, guys? 30 byte. Understand, everyone? Let's suppose this is the Ethernet header. Which header, guys? Ethernet header. Let's suppose size is 100 byte. Suppose. Fine. If we attach the ISL header here, now what is the size? 130. 130. I hope you guys understand. If we are using ISL add how much data, extra data? 30 byte. How much, guys? Tell me. 30 byte. Clear? These 30 byte is also divided into two categories or two parts, header and trailer. 26 byte is header and 4 byte is trailer. 4 byte is trailer. Understand, everyone? Tell me yes, no. 4 byte is trailer. Fine. So that's the reason we are not. If anyone asks you very simple question, why we are not using ISL, what will be your answer, Shekhar? Why we are not using ISL nowadays? Anyone?
Because it support only 30 bytes.
Shekhar, are you telling something?
No, no. So I don't know. Maybe the Ethernet frame is 32 bytes.
No. So try to understand. See, if we are talking about ISL is a Cisco proprietary, but even Cisco is not recommending ISL. Cisco is also telling please use .1q. Why? Because if you are using .1q add only 4 byte extra information with your original packet. But if you are using ISL, it use 30 byte information. So try to understand na, if you are using ISL, your packet size will be large compared to .1q. Understand, everyone? So that's the reason we are not using ISL. Understand? Everyone?
Yes.
So what is the conclusion here? What I'm trying to say, conclusion is, if you are performing the trunking perform encapsulation. But how? Encapsulation is performed either on the basis of ISL protocol or either on the basis of .1q protocol. Fine. ISL means if you are using the ISL, what ISL will do? Let's suppose this is the Ethernet header, original Ethernet header. Size is 100 byte. And if you are using ISL add 30 byte more information. The total size of the packet is 130 byte. If you are using .1q, how much extra data? Only 4 byte. So let's suppose this is the original packet and 4 more information. Total size is 104 byte. So that's the reason we are using .1q instead of ISL. Function is same. Function ISL also perform tagging. .1q also perform tagging. Getting my point? But .1q add how much byte data? 4 byte, and ISL add how much byte? 30 byte. Understand, everyone? If we are talking about the .1q is also divided into two part, or you can say .1q looks like this: 2 byte and 2 byte. 2 byte is known as TPI, and this is TCI. TPI means tag protocol identifier. and TCI means tag control identifier. Getting my point? Guys, what is the size of .1 queue? 4 byte.
4 byte.
2 byte is TPI
Okay.
and last 2 byte is TCI.
TCI.
TPI means tag protocol identifier, that is tag control identifier. Fine. Now, tell me about the TCI. If anyone asks you what is the use of TPI, it tells us which protocol we are using, .1Q or ISL. This field tells us
Dot one
about
q.
which protocol we are using, .1Q
Dot one
or
q.
ISL. Now, what is TCI? TC, if we are talking about the TCI, TCI looks like this. TCI looks like this. 3-bit, that is COS, 1-bit, that is CFI, and last 12-bit, that is VLAN ID. That is VLAN ID. This is the COS field. COS field tells us about the quality of services. This is the CPI. CFI. CFI stands for Canonical Format Identifier. This is the old technology we are not using. Last is 12-bit, that is VLAN ID, and this is the field which is telling about the which VLAN you are using here. Which VLAN you are using here. Getting my point, everyone? Tell me. Sekhar, Sandeep, understand? .1Q.
Yes.
So, what is the main difference between ISL or .1Q?
ISL is 30-bit long. Dot one
Because
Q is 4
ISL
bit.
is a Cisco proprietary and .1Q is a open standard.
Open standard.
ISL does not support untagged traffic. Tell me. Untagged traffic not supported here. And
Okay.
.1Q support tagged traffic.
Untagged traffic not supported.
Sorry, untagged traffic.
It's supported by dot one Q. Okay.
Now, ISL main difference. ISL do not support native VLAN
Okay.
and .1Q support native VLAN. Understand? Sachin, I hope you are not understanding this one. Native VLAN concept.
Yes, sir. Not understanding.
Yes. Wait, tomorrow I will explain you about the native VLAN. Then after you will understand why we are using .1Q. Understand? But for overview, I am telling you, just let's suppose this is the switch 1 and this is the switch number 2. Fine. Let's suppose there is a VLAN number 1. VLAN number 1 is by default VLAN.
Yes,
Yes.
sir.
And VLAN
Yes.
number 1 is a native VLAN by default. Fine. By default, between basically by default between the switches, what is happening, multiple messages are exchanging. Let's suppose CDP, DTP, VTP, multiple messages are exchanging here between these switches. Understand? So if you are using ISL here now, what ISL will do? Let's suppose this switch one is generating the CDP message.
Sorry.
Fine. So what ISL will do? ISL will perform tagging for CDP as well. So if ISL will perform the tagging for CDP, VTP, DTP, then definitely there is a congestion on the link. So that's the reason we are not using ISL here. If you are using .1Q and by default VLAN number 1 is here, and every message CDP, DTP, VTP, every message is a part of VLAN number 1. It means native VLAN. So in case of .1Q never use, never perform tagging for these type of packet. So you can avoid congestion on the link. Getting my point?
Yes, sir.
So that's the reason we are using dot 1Q. I hope everyone understand. Tell me.
Yeah.
Okay. So basically tomorrow we will continue. We will cover the VLAN lab as well as trunking lab as well. Fine, everyone.
Sure. So will you share any PPT at the
How
end of
we
the
can
class,
configure
or
the
it will
trunk,
be
how we can perform the. Yes, I will share the PPT with you. Okay.
okay? Thanks, man.
Okay.
So
And
like cam
Sandeep.
table,
Mhm.
hello, like a cam table, the switch also keeping one table for the VLAN. Is that correct?
Sorry,
So
cam table. No,
like a cam
basically
table.
for
Uh,
VLAN which is not performing creating any types of VLAN separate table.
okay.
Okay, you can just check all the VLAN information in the show VLAN brief command, and all the VLAN database is stored in the flash memory of the switch.
Okay. So we is okay. So it has to go and read that database always.
Yes, you can go and you can read the database from there only. Okay, clear everyone?
Yeah. Okay, sir. All right.
Okay, so Sandeep, I hope you already recorded the class. I will ping you the exact website name. Okay, from there you can let me check the name of website here.
You can post it in the group, so I can put it there.
I will say I'm checking.